Hey friends, as you can see, I'm in the classroom for today's problem string. Just wanted to remind you that this is not going to be a horrid problem string. I would say this is going to be an extraordinary problem string, or maybe a beneficial, or terrific, or amazing. So I just found this little poster and I had to show you all because I thought it was awesome to remember all our juicy words. Get rid of those boring words. Okay, so let's start with a really easy one. Just like always, make sure you have something to write with. Make sure you have a piece of paper, and it could be a pen or a pencil, but afterwards, please take a picture or just type it up in a Google Doc to submit it for me. First one, super simple. We're going to do 32 times 10. Okay, most of you will know 32 times 10 is 320. Pat yourself on the back if you knew that. And friends, one thing that's really important to remember is that we look at how much we're multiplying the number by. So let's do 32 times 100. Go ahead and write that. So 32 times 10 is 10 times 32, or 320. 32 times 100 is 100 times 32, so 3,200. And remember, we discussed in the past that number of zeros correlates with the number of zeros in our product. Let's pause here and talk about what this word means. Exponent. We talked about this a while ago, so this is review, but I'm glad we're reviewing it now. An exponent is a number or symbol that indicates the power to which the base number is raised. For example, in this expression, the exponent 2 indicates 3 is raised to the second power, meaning 3 times 3. So, if we have 3 times 2, it's different than 3 to the second power. If it's 3 with the exponent of 2, that small number up above, that tells us what we do is 3 times 3. We're going to keep exponent in mind. Say it with me. I'll say it, then you say it. Exponent. Nice. I heard you, Drake. Okay. Thank you, Taryn. Exponent. Thank you, Landon. All of you, thank you, Emma. Exponent's going to be really important for today's problem string. So, I want you to write 10 to the power of 1. Go ahead and write 10 to the power of 1. 10 to the first power. 10 to the first power literally just means 10. We're not multiplying it by anything. 10 to the second power. Go ahead and show me what that would be. If you wrote 10 times 10, because second power, we do it 2 times, it would be 100. If you got that, pat yourself on the back. All right, let's do 10 to the third power. Some of you are catching on. Go ahead and write that. Pause anytime you need to, friends, just like always. 10 to the third power. If you got 10 times 10 times 10 equals 1,000. You guessed it, right? Because this tells us how many there are. There's 1, 2, 3. All right, up the ante a little bit. Let's do 10 to the fourth power, then we'll move on. Write it out, show me on paper. Please show your work as well, not just the answer. And remember, we're always double checking in with those zeros. So you'll probably notice it's just a shorthand way of telling us how many zeros there are. 10 to the fourth power, 10 times 10 times 10 times 10. We need to look for 4 zeros, which is the same thing as 10,000. Please take a minute to solve this one, my friends. 32 times 1,000 And then once you've solved it, I want you to write it differently using exponents. Pause anytime, then come back when you're ready. Now I'm thinking out loud, like I know this means there's 32 groups of 1,000. So wouldn't that be the same thing as 32,000, right? And then I'm double checking my thinking with the number of zeros. 3 zeros, 3 zeros, yes. But wait, how do I write that with an exponent? Some of you will remember 32 times 10 to the third power. Because 10 to the third power is the same thing as 1,000. 32 times 10 to the third power is the same thing as 32,000. Now some of you might be like, what are you talking about, Miss Miller? Let's slow that down for just a second and think about it. 10 times 10 times 10 is the same thing as 100 times 10, which is the same thing as, let's write it over here actually, 1,000. So there we go. Okay, bugs, we're going to keep it rolling. I'm going to ask you a division equation now and ask you to write it with exponents. So it's 64,000 divided by 10 Please solve the problem and then write it with exponents and see what you come up with. Some of you will say, well, Miss Miller, if we're dividing it by 10 instead of multiplying it, we remember we're going to end up moving the decimal place over 1 to the left, so we get rid of 1 0, which is correct. If we take away 1 0, it's 6,400. Pat yourself on the back if you got that. And then we're thinking of, how would we write that? Well, wait, what's 10? We decided earlier that 10 was the same thing as just 10 to the power of 1, right? So another way to write that would be 64,000 divided by 10 to the power of 1 equals 6,400. We're going to get a little more complex now, friends. Let's do 64,000 divided by 10 to the power of 2. You just did 64,000 divided by 10 to the power of 1, and you realize that was 6,400. Now let's do 64,000 divided by 10 to the power of 2. Go ahead and solve it. Now remember, you still have your notes written down, so you can double check. What does that mean? What does that mean, 10 to the power of 2? I want you to write this out all the way. It's going to help your thinking. 64,000 divided by 10 times 10 equals, that's the same thing we know as 64,000 divided by what? 100. And so just like we did in the previous problem, we have to remember, when we do this with our exponents, all that 10 to the power of 2 is saying is 100. And all that we do when we divide instead of multiply is take off 2 of those zeros, because it's getting 100 times smaller. We're dividing it by 100. Instead of getting 100 times bigger, like when we multiply, we're dividing it by 100, getting 100 times smaller. So we're moving it over 2 decimal spots. So the answer is 640. If you got 640, pat yourself on the back. All right, let's keep moving, friends. Let's do 64,000 divided by 10 to the power of 3. Show your work, write it out, and then come back. We know this is saying the same thing as 64,000 divided by 10 times 10 times 10, which is also known as 64,000 divided by 1,000. All right, so we're getting 1,000 times smaller than the original number, right? 1,000 times smaller because it's being broken up or divided by 1,000. So we know that's 3 zeros in 1,000. So we're moving left 1, 2, 3. Or 64,000 divided by 1,000 equals 64. Because we're taking away 3 zeros, the place value moves 3 times to the left because it's getting smaller, 1,000 times smaller, or the amount of zeros get removed with division. The opposite way, they get added with multiplication. The answer is 64. Pat yourself on the back if you got it right. All right, we're going to use 2 more numbers to show a similar perspective and see what you got, friends. All right, please show me 4.5 times 10 to the power of 1. Some of you got this right away. Miss Miller, you're trying to trick us, right? 10 to the power of 1 just means 10. So 4.5 times 10, we're getting 10 times bigger. Remember what we do with the decimal point. Our place value moves 1 over to the right because the number is getting 10 times bigger. Instead of 4.5, this whole number is shifting and it becomes 45. What was in the tens place, what was in the ones place goes to the tens place for 40, and what was in the tenths, remember, the decimal gets moved to the ones for 45. All right? Now 4.5 times 10 to the second power. Use what you know. Go. A lot of you will make this connection. 10 to the second power is the same thing as, pause anytime and then come back, 4.5 times 10 times 10, which is the same thing as 4.5 times 100. 100 times bigger than 4.5, we're going to move that decimal spot 2 spots to the right because our number is getting 100 times bigger than 4.5. So we get 450. Nice. The same way is if the number was 4 and it got 100 times bigger than 4, it would be 400. But this is 4.5, right? 0.5 is the same as a half. It's not quite a full one yet, but when we get 100 times bigger than 4.5, we get 450. Or the place value shifts 2 places over to give us 450. All right, let's do 4.5 times 10 to the third power. I know you got this one. From the previous information, I know that you know that this is the same thing as 4.5 times 10 times 10 times 10. What do you do next? If you got the answer of 4,500, you got it. So we can see the shift, the decimal spot, can see the shift to the right by the number of places equal to the number of zeros. So it shifts to the right, the number of places equal to the number of zeros. We've been talking about this. It goes from 4.5, it shifts over 1, 2, 3 to give us 4,500. All right, nice work, friends. Erase, erase, erase. And we're moving on to our final one. Stick with me. You're almost done with problem string 8. Nice work. Okay, let's do a division. 2.7 divided by 10 to the first power. When we think about exponents, you're going to go, Miss Miller, I know. We know 10 to the first power is the same thing as 10. 2.7 divided by 10. So, when it's divided, the decimal point shifts to the left by the number of places equal to the number of zeros in division. How many zeros do we have here, Taryn? So we just shift to the left. 1. 1 0, 1 spot. So 2.7 divided by 10 is, I'm sorry, I made a mistake, is 0.27. Let's do 2.7 divided by 10 to the second power. The number of zeros determines, and one thing we can do to help us out is remember that 2.7 divided by 10 to the second power is the same thing as divided by 10 times 10, or 100. So how many zeros are in 100? 2, right? So we need to shift to the left. Oh, our answer will be 0.027. Do this next one on your own and tell me what you get. I'm going to see who gets that one. .7 divided by 1,000, or 10 to the third power, same thing, means that we are dividing and there's 3 zeros, so we shift that many places over to the left. 1, 2, 3. So our answer, my friends, if you got this right, give yourself a big smile. 0.0027. Thanks for hanging out with me today. Air 5.